Hello, and welcome to the Scientific Odyssey. The Scientific Odyssey is a mini-part journey into the history and philosophy of science. My name is Chad Davies, and I'm the writer, host, and producer of the podcast, where we consider the ideas, processes, and results of over 2,500 years of scientific inquiry and discovery. Series 2, A History of the Atom. Episode 1, The Philosophical Atom. With this episode, we shift from a discussion of the basics of scientific inquiry into an examination of the history of a particular scientific idea. The idea that we will be considering is that of the atom, beginning with the Greek and Buddhist atomists and ending with the modern quantum mechanical model. Before we begin a discussion of the idea of itself, I think it's useful to share a few introductory thoughts. First, why atoms? When I began to think of this podcast, one of the things I wanted to consider was the biggest of the scientific ideas, those theories, models, and organizing frameworks that make up the foundations of modern scientific thought and form the basis of our modern worldview. While the list of these ideas is probably a matter of some debate among scientists, I don't think there is anyone who would argue that the idea that lies at the very heart of our scientific worldview is that matter is made up of atoms moving through space and interacting to form everything we see. Hence, I think it is really important that this be our first topic of investigation, as so many other big ideas either rest on it or interact with it sometime in their story. For example, while Darwinian evolution doesn't require an atomic worldview, the understanding of the encoding of genetic information and the mechanisms of mutation certainly do. Without the idea of atoms, we wouldn't understand DNA. Another case where our understanding of the atom is essential is that our knowledge of much of the universe beyond the motions of objects through space requires that we know how light interacts with matter. Without Bohr's model of the atom, our ability to get at this information would be severely limited. If we think about it, the entire field of chemistry basically requires an atomic understanding of matter to get beyond the first basic laws. So in short, it seems like this is about the logical place to start. Second, a word or two about history. This series of podcasts will be a history of an idea, and like any but the most exhaustive of histories, it's going to leave some things out. Thus, this will really be just a history rather than the history of the atom. My focus will be on ideas and models and how they were developed. Part of history is about telling a story and understanding the narrative, and with that in mind, it is useful to know the goal of the narrative. In this case, the goal is to understand how science was done in order to arrive at the conclusions reached. The idea of this series is to show how, initially, natural philosophers and then later, scientists came to understand the atomic nature of matter and how that led them to an even deeper understanding of how our universe is structured. I want to try and give you a sense of how each person thought and what evidence led them to the conclusions they reached and how that led to further investigation. Third, how does the narrative get told? One of the challenges to writing a history of something is to figure out how much detail to include. I liken this to flying in a plane. When you're at some really high altitude, say 10,000 meters, you can get a sense and feel for the grand panorama of the landscape. You can see the big picture and how things generally relate to each other. The problem is that you can't see many of the details, and thus you can really miss some important features and relationships. On the other hand, if you fly only a little higher than the treetops, you see all the variety in parts, but unless you're traveling pretty slow, it can be overwhelming and you can lose track of how it all fits together. Fly too slow and you stall the plane and crash. So the question is one of picking the right height to tell the history. You want to be high enough to get a lay of the land, but low enough to see the details in the relationships. Fast enough not to get bogged down, but slow enough to make sure you see the important stuff and why it's important in the first place. What I'll try to do in many of these podcasts is to start with some altitude and then descend to pick up the important details before climbing again to put it all back in perspective. Finally, what to do with philosophy. Atomic theory is actually a pretty philosophical thing, especially at the beginning and then towards the end. It is deeply intertwined with two questions. What is the nature of reality, and how do we know about that? In the field of philosophy, the first is a question of metaphysics, while the second is from the area of epistemology. As I'm not a philosopher by training, I won't claim to be able to address these questions with the subtlety and insight a professional philosopher would, but I will try to include the appropriate philosophical considerations when necessary and helpful, especially in the first 2 episodes of this series. The nature of matter is a difficult thing to investigate, and as we will learn, the philosophical preconceptions and biases of the various investigators drive much of the direction of the story. So, what will this series seek to explore? To paraphrase a character in one of my favorite TV shows, imagine it's a warm afternoon in Anatolia. Beginning from that time, we'll travel over a 2,500-year course of human thought that starts with the first recorded expressions of natural phenomena having natural causes to a description of light, matter, and energy that is, to quote J.B.S. Haldane, not only queerer than we suppose, but queerer than we can suppose. So, where does our story begin? It starts with a Greek philosopher named Thales. While we don't actually know too much about Thales, we do know that he was a philosopher and keen observer of nature in the city of Miletus, on what is now the western coast of modern-day Turkey. Because of these things, he is also reported to have been a savvy businessman who made a fortune understanding that the weather had a lot to do with the olive harvest. He was born in the mid-620s BCE and is considered by some, notably the Greek philosopher Aristotle, to be the first of the Greeks to participate in systematic philosophy. While we no longer have any of his writings except as quotations in the writings of other later Greek philosophers, it seems clear that from their commentary, Thales was the first person in the world of classical Greece to attempt to explain the natural world around him without resorting to the use of supernatural or mythological explanations. This is a really important moment in the history of human thought. It's the first step onto the path that eventually leads to modern science. For Thales to put forward the idea that all things a person could experience arose from the primordial substance of water, and to have an explanation of this idea that was based on things he had observed in the natural world, is a gigantic step away from the paradigm that what happened and what you saw in the world was due to the whim of some supernatural being. Think of it this way. You no longer had to think that the west wind blew because the will of Zephyrus, who brought with him the spring and summer. Instead, said Thales, it was due to some natural force or impulse that didn't much depend on how much grain and oil you had sacrificed on any given day. Moreover, it might be that this natural phenomenon might have, maybe, some regular behaviors that you could learn and understand and thus plan for. This is how Thales was said to have made himself rich. According to Aristotle, the philosopher was supposed to have recognized that the early spring and summer weather would result in a bounty harvest in the olive crop, and so he pooled his resources and rented every single olive press in the area at a discounted rate. When the record harvest did in fact come in, all of the farmers of the region had to come to him to have their olives pressed into oil, a service only Thales could now provide. As you might imagine, Thales made quite the killing in pressing fees. Ancient Greek sources also tell us that Thales may have been the first Greek astronomer, and they attribute to him the ability to predict the time of a full solar eclipse at the specific instant of a great battle between two armies. While Thales would certainly have used the work of earlier Babylonian and Assyrian astronomers, it is telling that his faith in the regularity of natural events led him to be able to be willing to make this kind of a prediction. Now, the details of Thales' arguments of why everything originated from water aren't really that important for our story, nor are those of the philosophers who followed him, who said that everything was made of air or earth or fire, or later, some combination of two or more of these things that they might have called elements. What's important is they didn't say that the material world came from the thoughts or tears or blood of the gods or something of that sort. In rejecting supernatural explanations, they moved human thought to a place where nature could be examined and tested so that its patterns and regularities could be documented. Thales was the first person we know of to set forth hypotheses that didn't require a special relationship with beings beyond this world to understand and verify. In summarizing the views of these earliest of Greek philosophers, it is Aristotle who wrote, quote, "Most of the early philosophers believed that the essence of all things could be reduced to material principles, that from which all things come to be, the initial stage of their generation and the ultimate stage of their degradation, while the state of the substance can change, the substance itself remains. That is what they hold to be the element and principle of all things. They believe, furthermore, that nothing is created and nothing is destroyed, since nature is forever conserved." This idea of conservation will continue to be held by various thinkers through the subsequent history of human thought, and be demonstrated via experiment a couple millennia later by Lavoisier. The next figure of some importance to us is Empedocles of Sicily. Building on the work of the Milesian and Eleatic schools of philosophy, Empedocles said that the world consisted of 4 equal elements, the aforementioned earth, water, air, and fire. He said that all observed change in the physical world was due to a mixing and separating of these 4 elements by the agents of love and hatred in a cyclical movement from unity to separation and then back again. Chemist Bernard Pullman cautions us not to think of these 2 agents as attractive and repulsive forces, as would be later described in the physics of electrostatics and magnetism, but rather as things that change the material nature of the mixture of the elements in order to change what the object is. As a side note, Dr. Pullman's book, A History of the Atom, will serve as a regularly cited reference for this series in the podcast. Pullman goes on to say that Empedocles' explanation of the assembling and separating of these elements requires certain realities to be acknowledged. First, all elemental substances were made of very small particles that are homogeneous, changeless, indivisible, and eternal. Second, these particles are separated by pores, somewhat like holes in a lattice or framework. Third, all material bodies are formed by particles of one element interpenetrating into particles of another element via these pores in such a way that the size of the pores and the amount of the interpenetration, along with the mixture of elements, determines the nature of the material body. In this, it should be understood that Empedocles is not talking about the later atoms of Democritus. However, his ideas will be foundational to that somewhat later description of both space and matter. Also, it is worth noting that in his description, Empedocles treats air in the same way as he does the other elements, thus giving it a particulate nature or description that was lacking in the thinking of many philosophers who had come before him. To Empedocles, wind was something. At this point, we're ready for the entry into our story of Leucippus and Democritus. Philosophers of the Milesian school, the ideas of these two are difficult to separate as we have no surviving writings from Leucippus, leaving us only with the references to his thinking in the work of Democritus and his contemporaries. Following most commentators on the subject, I'll treat them together. Their idea, in the words of Cicero, was that there were two principal things, the filled and the void. In more contemporary terms, we might say that there was matter and empty space. Matter, they said, was made of atomos. So what did this mean when they said this? The first point to make is found in the word atomos, or more accurately, atom, which comes from the Greek meaning not cut or uncuttable. In this description, all objects in the physical world were made up of particles that could not be cut or divided. As in the case of Empedocles, they were indivisible, though it should be said, not with liberty and justice for all. In addition, atoms were described as being hard and incompressible, not having parts, and of homogeneous composition. The number of different types of atoms were infinite, and all the things we see are made up of different combinations of them. Finally, all atoms of a given substance were identical in every way and differentiated from atoms of other substances in shape, arrangement, and position, as well as size and possibly weight, though this last characteristic may have been added much later by the Greek philosopher Epicurus. An important distinction to understand here is that Leucippus and Democritus have moved away from Empedocles' four elements model. In fact, it seems that they may have abandoned the idea of elements as pure, unalloyed substances altogether, though this is somewhat unclear in their writings. The second, equally important idea of principle was that any space not occupied by an atom was void or empty. This meant that atoms could be in infinite and unending motion through the void. This motion was thought to be entirely random and determined only by collisions with other atoms. One way to visualize this might be to think of ping pong balls in one of those lottery selection machines where the balls bounce off of and around each other in every different direction. In many ways, it is really this idea of the void that was the true innovation in thinking on the parts of Leucippus and Democritus, and it was absolutely essential to their description of not just the nature of matter, but also how the natural world was structured. So why did these two philosophers come up with this description of the universe? It all has to do with an argument about change between two philosophical schools. One school, led by a man named Heraclitus, said that change was a fundamental reality of the world. He said that if you look around, things are always changing, and that there had to be a reason for that, and there must be an explanation of how it all happened. The other school of philosophy, led by a guy called Parmenides, said that change was really just an illusion. Yes, he said, if you look around, you'll see that things are changing all the time. But then he asked a really interesting question. He said, how do you acquire this information? Your response, of course, is going to be, well, through my senses. Then he would say, but don't you know that your senses deceive you? For example, think of a shimmering mirage over a hot beach on a summer day. Parmenides said that our senses were unreliable and couldn't be trusted, and so change was just an illusion. While this idea may seem kind of absurd to us now, it was based on the thought that there could be no void, as that equated to non-being. In Parmenides' words, if the void is, then it is not nothing. Therefore, it is not the void. He then argued that if there wasn't a void, then there was nothing for things to move into, and so motion was impossible. Finally, he would say, if there's no motion, then there can be no change. What you can see here is that Parmenides' idea is based in reasoning. It is a rational argument that discounts the validity of information acquired through the use of the senses, what we called empiricism in an earlier podcast. This conflict between rationalism, as it is known, and empiricism will be a common thread throughout the history of science and the philosophical considerations that surround it. What Leucippus and Democritus are trying to do with atomism, as it is known, is bridge the divide between these two positions. For Democritus, the Atomos, or atom, was an unchangeable entity in the way that Parmenides would like. However, in allowing there to be void, this unchanging entity could cause change through motion and combination. These combinations and recombinations would explain how objects are allowed to become something different than they once were. Our ability to sense the things that make up the world happens because atoms that were once part of an object would leave it and travel to our sense organs and thus impart information about the object they were formerly associated with. As this podcast is being released the weekend just prior to Thanksgiving here in the United States, let's consider an apple pie as an example because, as you may know, that's what you need in order to understand the universe. A freshly baked apple pie is one of the more glorious and wonderful things a person can ever smell. But how does one smell this most divine of confections? Democritus said that the way in which this occurs is that there will be atoms that will come into contact with and interact with the freshly baked pie in their constant motion. In this interaction, the atoms will acquire some of the characteristics of the pie prior to leaving it. Once the modified atoms have left the pie, they will eventually, again through their constant motion, make their way to your sense organs, most notably your nose, and interact with it. In this interaction, the modified atoms will modify atoms presently associated with your nose, and so you will smell the excellent combination of sweet and fruity and spicy that sets your mouth to watering. Just out of curiosity, is your mouth watering now? Democritus doesn't have an explanation for that, but if you need to take a few minutes to break and get a slice of apple pie, I'll understand. You are, of course, participating in the ancient endeavor of inquiry by doing this, after all. While the idea of atomism is a powerful way of explaining change, it should be noted that the idea is not something that we would call scientific in today's terms. As a hypothesis that attempts to explain the nature of matter, it offers no testable predictions and little in the way of an experimental or observational program that would shed light into its correctness. Atomism is an examination rooted in the philosophical considerations rather than what we might call scientific ones. Nevertheless, so powerful idea is it that it will survive over the next 2,500 years, even as many philosophers and theologians argued against it, to inspire first the natural philosophers of the Renaissance, and just after that, the Enlightenment scientists who would put it on a solidly established empirical footing in the 19th century. To close this podcast, I would be remiss if I were to leave you with the impression that atomism was only or purely the work of the Greek philosophical mind. At roughly the same time as Thales was giving thought to the primal source of all matter, Indian and Buddhist scholars and thinkers were also beginning to explain the material world in atomist terms. As in Greece and Anatolia, the full development of this track of thinking would occur over a period of about 5 centuries. During this time, several different schools of thought regarding this arose, with some mirroring the Greek idea of there only being a limited number of types of atoms, each with as many as 24 different characteristics. Others were more along the lines of Democritus' thinking, in that there were an infinite number of different types of atoms. There's a good deal of scholarly discussion as to which culture might have thought of the idea first, and how much influence one culture might have had on the other, if any. Whatever the case may be, I find it fascinating that in both cultures, very similar ideas arose wherein people began to try to understand their world at a deeply fundamental level. It should be noted that in none of these cases did the philosophers make the argument that just because there could be naturalistic explanations for what people saw, that ruled out the existence of gods. In Greece, this development would have to await the mind of Epicurus. Additionally, there was much debate as to whether the soul was also atomic in nature, and if so, whether things besides people had souls. For our purposes, it is enough to recognize that in India and in the regions around the eastern Mediterranean Sea, there was a new way of looking at the world that emphasized natural explanations of physical phenomena, and that this led to trying to understand the composition and motion of that physical reality through an atomistic explanation. All of this may lead you to ask a really good question. If all this happened before, say, 300 BCE, why did it take so long for science to figure out atoms? I mean, we don't actually get there until the 19th and 20th century. That's going to be the subject of our next podcast. However, let me tease that episode by saying that not everyone was convinced by the arguments of Democritus, and they pointed out some of the places where explanations weren't as good as he thought they were. In the next episode of the podcast, we'll try to bridge a huge span of time from classical Greek philosophy through the pre-scientific works of the Arabic Hakim to the return of natural philosophy in Western Europe, in an episode I'm calling The Long Leap Forward. Until next time then, full sails on your journey.